Okay,
All
everybody,
right.
it's my pleasure to turn this over to Mary Grygleski and Mark Needham, our honored guests. Thank you so much for presenting, and take it away.
Thank you, Robert. Thank you, Altinity. Thank you. So I'll do a quick start now, right, Mark? And just a quick intro first, just 1 minute. So welcome to the Building a Real-Time Analytics Application with Apache Pulsar and Apache Pinot. My name is Mary Grygleski, and I'm a developer advocate at DataStax. And so I'm a streaming developer advocate at DataStax. And if you're familiar with the company, we are a leading data management company that specializes in database as a service, NoSQL, big data streaming now, and cloud native platform. So if you're familiar with Apache, Cassandra, we are the one, and we have our managed cloud platform, as well as now we have Apache Pulsar on the managed cloud. I'm based in Chicago. I'm also a Java champion and president of the Chicago Java Users Group. I'm really heavily involved with the community, and I love the community. And before this, I was a software development engineer for over 20 years, primarily in Java in different space. So my area is mostly in event streaming in reactive kind of space. So these are the links as to how you can get a hold of me, but we'll share the slide deck afterwards. So thank you. And now I pass it on to Mark.
Hi, so yeah, my name is Mark. I work as a developer relations engineer / advocate at StarTree, who have a hosted cloud service for Apache Pinot. Yeah, you can see the rest of the stuff about me there. Yeah, I guess my most interesting recent thing is I've started making these short YouTube videos, Learn Data with Mark. So if you like those, you can have a look there. So otherwise, let's get started. So we're going to start with the definition. So this is Gartner's definition of real-time analytics. So they have it defined as the discipline of applying logic and maths to data to provide insights for making decisions quickly. So like, okay, what exactly does that mean if we translate it to practical terms? So I find it's quite useful. If we think we've got about events, so like everywhere there are events, maybe I ordered something from a website, or I captured a reading from a thermostat, or I don't know, I walked somewhere. Like all these things are events of things that can happen. And events are all right on their own, but generally, like they're more interesting if we can get some insight from the event. Like what can we find out from the event? And then once we've done that, we want to be able to take some sort of action based on the insight that we've derived from that event or from that stream of events. So that's what we're going to be talking about in our talk. And something to keep in mind is that in this world of real-time analytics, the value of data reduces over time. So like right when the event happens, so i.e., hey, I did a search for something, or I bought something, that's when it's most interesting. That's when I can actually do something with the data. Like it's not so interesting to know tomorrow, for example, oh, Mark wanted to buy something to eat, and you find out like 12 hours later, so it's too late, right? So in this world, like we need to be able to know very, very quickly what happened so that we can do something about it. And there are lots of different people who are interested in this data. So it could be like analysts at a company, like operating like a website, for example, like wanting to be able to see, like, hey, who's wanting to order stuff that we might be able to provide to. It might be the management. They're like, hey, I want to know like what's going on in the business. And then most interestingly, it might actually be the users. Like, can we feed the data like back to the users to allow them to interact with an application more, or maybe even feed them information back again that they can do something with. And there's like this, we came up with this quadrant of the types of applications that we see people building. So they kind of fall into these 4 areas. So along the x-axis, we've got it can be an internal application, or it can be external. And then on the y-axis, we've got it can be human-facing, or it can be machine-facing. So in the top quadrant, so machine-facing and internal, that's generally like observability stuff. So like Datadog type things. It's like, hey, I'm getting some metrics on what's happening, and maybe it's being used by SREs in my team, for example. If we come down into the bottom quadrant, we've got the human-facing internal. So this is like inside a company, but I want to know what's happening now. Like I don't want to wait until tomorrow to know what happened. I want to know right now. So this is like the real-time dashboard space. Coming over to the right-hand side, so this is where we're doing external, the user's external. So it could be, if it's a machine, it's maybe feeding the data into a recommendation engine or fraud detection. And then finally, if it's external and a user, maybe it's an order tracking service. So, hey, I ordered my thing from Uber Eats and I want to see like the statuses of what's happening with my order. Or maybe I want to see where exactly, where you see the driver. Where's the driver? How many stops away are they? And so if we just run through some examples of people doing this. So LinkedIn is a good example of this. So like the who viewed your profile chart or graph. And so on here, it's showing like who's been looking at your profile, like up to like basically up to now. So if I went and looked at someone's profile, they'd be able to see like straight away that I'd seen it. And then it does some sort of like abstraction on top of that, right? So it says if you're paying like for LinkedIn Premium, they're like, here you can see like all the names of the people who viewed it, and if you're not, then you can only see some of them. And this is operating like this is like a user-facing analytics application. So it's operating at very high scale. The news feed is another example of that. So like they want to like show up stuff at the top that you are likely to interact with, so that you're going to keep on using LinkedIn more. And then if we come over to like more of an like it's not quite internal, but less users is the recruiting tool. So we've got like talent pool report, and we can see sort of up to date, like what are people doing, like where is demand high for in terms of location or in terms of types of jobs. And so they can narrow down, if you're a recruiter, to try and figure out like where should I be targeting people. And then let's just do one more example. So we do Uber Eats as well. And so the idea here is I've got like this dashboard. So say I'm running a restaurant on Uber Eats, and I want to be able to see like what are my sales and what are my top selling items. Is there any feedback on the menu? But most interestingly here is like missed orders or inaccurate orders. And if we can see those in real time, then it allows us to actually take like a useful real-time action. So let me get a coupon out to those people that we missed their order, or let me go and apologize to them, or something like that. So we'll just, and then Stripe is another one as well. So sort of using this for financial data. But let's skip through to here. So just going to run through what are the properties of building these systems. So the idea is we're going to have data in a stream. And so in our talk, we're streaming data into Pulsar, and we want to be able to get that through the system very, very quickly, right? So that we can do some queries against that data. So we want to be able to get the data in really fast, query it like in sort of OLTP type speed of queries on OLAP data. And then we want to be able to scale it, right? We want like tens of thousands of users to be able to run their queries. So how do we build one of these applications? So we've got here, like in the middle, so we're going to be using Pulsar and Pinot as the talk title suggested. And then around the side, we're sort of talking like, what are the properties that we would expect? So we've got real-time ingestion. We're working maybe on very, very wide columnar data. We want to be able to ingest it very quickly. And then we've got like, we want to be able to operate at thousands of queries per second, very fresh data, and then low latencies on our queries. So I'm going to hand over to Mary now to explain how Pulsar fits into our architecture.
Thank you, Mark. Yeah, so now we're on to talking a bit about Apache Pulsar. I won't spend too much time. It's tons of information, but I want to give you a taste of it. So as such, right, folks are probably more familiar with Apache Kafka. And what is Apache Pulsar? But as you can see over here, right, it's again, it uses a PubSub type of approach, right, architectural approach. And also with this PubSub, then we have brokers. By default, it's only one broker, but the thing is with Pulsar, you can also configure multiple brokers, and then they're like communicating through, use of topics, right? You need to, producer will be emitting messages to the topic, and consumers will need to subscribe to the topics accordingly. Topics can be partitioned too as well. So, and they can be persistent and or non-persistent as well. So as you can see, this is a quick kind of overview, few parts to it. You see the producer, consumer, clients, that's what you write code to it, but inside there's broker running, and then there's also, it relies on Apache Zookeeper to help with managing all of those log messages, and which explains like why it is actually Pulsar is more of a solution to be used in the cloud environment, because of Zookeeper managing the huge amounts of data, the log messages, everything, then it offloads Pulsar from having to worry about it. So as you can see over here too, I'm sorry, I meant to say Bookkeeper, I'm sorry, I kind of Zookeeper, Bookkeeper, kind of almost same name, but of course, Zookeeper is the one that manages all of these, all these entities in the cluster running, Pulsar, the cluster and information configuration, all of these things. And let me kind of correct back is that there are all the bookkeeper bookies. As you can see there, each unit of bookkeeper units is called bookie, and bookie will segment off all of these log messages. So when it comes to light scalability, it's very, much easier, like in terms of management, because you can scale independently without kind of dragging the whole thing down. So just in a nutshell, that's why we want to use Apache Pulsar. And maybe next page, please. Okay, so let me kind of introduce you a bit then more into about what Pulsar is. It is an open source project created by Yahoo back in 2010s in that time frame, because at the time Yahoo was already dealing with tons of data by services such as Yahoo Marketing, Yahoo Finances, all of these huge amounts of data. They are already using the cloud, but at that point in time, there wasn't any kind of cloud native ready type of event kind of streaming messaging system. So they developed their own, and that's Pulsar. And of course, it has evolved over time. So in 2016, Yahoo donated it to Apache Software Foundation, and then within short 2 years, it became a top level project. And it explains, because it has a very cloud native design to it, is cluster based. It also supports multi-tenancy, so it organizes your data already kind of very natively, so to speak. And also, again, I talk about how it separates out the compute and the storage. So the storage part is handled by Apache Bookkeeper. And then when you write your code, you're not bound to only writing one thing, right? Because it's a very kind of what you call decoupled type of nature. So you write your clients, and it can be in Java, even though the runtime broker is JVM Java based, but you can write your client using Java, using .NET, C#, Python, Go, and other community supported language client libraries as well. Also too, is that, with messaging too, it guarantees message delivery. The broker is very strong, in terms of like resilient. If you send the messages over, the network is down, everything, it guarantees, it makes sure that messages gets delivered accordingly to those who have subscribed to the messages. And also too, Pulsar has this lightweight serverless function framework. So if data flowing through the pipeline, you need to transform it. You don't need to write your own thing. It's already there. The Pulsar function, you can leverage it. It's very lightweight. It kind of takes on concept with like AWS Lambda, sorry, and all the Google functions like that. And then also too, it has a tiered storage offloads approach. So if messages are kind of outdated is code, then Pulsar will essentially move the messages over to cold storage. So it kind of, relieve spaces in a hot, warm area for more, urgent data to be processed. So just to sum up, Pulsar is a very much, it separates out the concern of the infrastructure for you. So as developers, especially here, we're talking about analytics. You are developers and you're more concerned with analytics. You only, kind of worry about the data coming in, streaming in huge volumes. Pulsar is poised to become, a really important and kind of very functional kind of event streaming platform for you in the cloud kind of environment. So yeah, can we have the next? Next step. Yeah. Okay. So
yeah. Sorry, you got like a two or 3 second latency between when I hear you, but yeah.
Sure. Okay. Yeah. Okay. I think it's good, right? Okay. I still have time. Okay. So I was just this one quickly. I just want to explain too. Now we're talking about using event streaming, and then for analytics such as like Pinot, we need to pair with a very efficient system to do all the messages ingestion, right? We're using leveraging event streaming. So let's take a look, right? If we're not using streaming, in the past, like for example, extract, transform, load, ETL processes, they ingest data and then they have to persist the data to disk or to a database or to file system, whatnot, right? And every time if you're writing data, reading data from disk, it will increase the time that it needs to kind of do the round trip, even though it means nanosecond, right? So as you can see, if we're not streaming, we're kind of dealing with, disk IO, and then you do, every time you need to do any kind of analysis, you need to select data again, process the data and persist the data again. It will kind of, you cannot avoid spending more time having to deal with it. However, if you use a true event streaming system, you are ingesting the data and you process the data as you come along in memory. So everything is a lot faster and it's also real time. And that's why we want to kind of pick like an approach using event streaming. And then when you're done, right, these pipelines you're building, you can output all of your transform data to a sink, and then from, so on and so forth. And then you can also build different pipelines. So the effect is that it's very, very fast and handles high volumes of data. So that's the goal. So, okay. And the next slide. Yeah. Okay, so back to you, Mark. So.
Oh yeah. Okay, back to me. So in a similar way, what is Pinot? So Pinot is an overlap database, and it processes the events coming from streaming tools like Pulsar, but it can also do batch like processing of data, like from Spark, or if you had a bunch of CSV files lying around, you could load it in there as well. Let me just quickly take you through the architecture of Pinot so that we've already understand the Pulsar one. Now let's understand the Pinot one as well, architecture as well. So we've got the data coming in from Pulsar, and it's coming in on these different partitions. And so the first two components, we've got a controller and we've got a server. And the controller is going to deal with, like, where does everything go? So it's going to come in these partitions. It's going to create a segment. The segment is a partition in Pinot. So that's its way of storing data. And it will then say, okay, segment 1 is going to go to this server, segment 2 to this server, and so on. And then it can also you can also set it up with a replication factor if you're running an HA. Similar to Pulsar, it's using Zookeeper to manage the metadata. So that's the controller. And then the server is where the data is actually stored. So when you're ingesting data, the server is doing that work, connecting to Pulsar using one of the client, and then bringing the data in. And then the third component that we're interested in is the broker. And this is where the clients send their queries to. So they send their queries to the broker, and the broker then works out, okay, I need to send this query out to these servers so that they can give me the answer, in this case, for the number of items that they have where the country is the US, send it back to the broker, and then the broker will then kind of aggregate everything together. So now we want to show you a demo of these tools working together to do something interesting. If you would like to follow along or have a look at this afterwards, if you go to this link, and we'll share it with the hosts afterwards, so they can send it out. And it's obviously in these slides, so we're going to be sharing the slides too. But we have this demo, and this is actually a real-time dashboard. So it's kind of sitting in imagine we're in the bottom left-hand quadrant, and this is the architecture of what we're going to build. So we've got a streaming API. We're going to get the data out of there using a Python application. But then we're going to use the Pulsar Python client to get that data into Pulsar in the middle. Then we'll connect it from Pulsar into Pinot, and we'll be able to effectively query the Pulsar stream from Pinot, and we'll build like a little Streamlit dashboard on the top. So that's the plan. Those are the components that we're going to build. And we're going to be using Wikimedia's recent changes feed. Now, obviously, the number of events that this is producing doesn't in any way get near the limit of what Pulsar or Pinot can do, but it's quite a nice one, and people generally understand what Wikimedia is. So it's kind of an interesting one to demo. And what it gives us is the stream of the changes that people are making on Wikimedia properties published using the server-side events protocol. So it's an HTTP stream of events. This is what those events look like. So we get 3 properties. So you get an event, an ID, and a data. And data is where we're mostly interested, and it has like effectively a bunch of JSON that we can consume. And so, yeah, that's what it looks like. So now let's have a look at the demo. So we're going to come in here, and we're going to open this file here. Is that big enough, Mary, or do you want it a bit bigger, do you think?
I think it looks good to me. Yeah, so. And folks can also adjust the size of your screen too.
Yeah. So shout at us in the chat if this is not big enough. So this is a Python script that will process the Wikimedia API. So just to walk you through what it's doing. So we've got this URL here. So maybe we'll just put this in the browser. So if I paste this in the browser. So this is what you get. Like, there are loads and loads of messages. They're coming in all the time. And as I said, you get an event, you get an ID, and then you get the data. So this is like a big JSON message. And so what we're going to do is we're using the requests library in Python. So we're wrapping a GET request around that URL. We say stream is true, and then we're using this SSE, so server-side events client, from Python, and it will effectively just give us an infinite stream of messages. So if we come over to my console and we say wiki, there you can see like it's the same messages. They're all sort of flying through. So you can see if we just scroll up, there is an example of a message. We've got meta, it's got a domain, wikidata.org, and this example, an ID, an offset. The offset is, I think they actually are using a streaming tool themselves. That's the offset in there, partition, request ID, and so on. So there's a bunch of data. So that prints it out to the console. But what we really want to do is get it into Pulsar, right? So I'm just going to open up our wiki to Pulsar. And I will let Mary walk us through what we're doing here. So effectively, we're doing kind of some parts the same.
That's right. Yes.
Some parts different. So
yeah, that's right. So in here too, we're doing Pulsar client. You connect to the broker in here, and right now we're not using the one with the SSL, but otherwise too, you can also connect, with SSL if you're on the cloud. Let's say if you're using like the DataStax, we have Astra streaming, so you can connect to using Pulsar with SSL to the cloud broker like that. So okay, and then the way you do it is actually not very complicated at all. You can do a Pulsar client. Once you get the handle, then you can create the producer. Essentially, too, you basically label like telling which topic you are going to publish to. So in this case, is wiki-events, right? And so over here too, then basically, when you're publishing, all you need to do is just doing the publish in here. And notice too, right, in here in the for loop in there, there's also, you set up your stream, right? And there, and then the payload, you set up your payload. And then when it comes time to send, you can just do a producer. The client can do a send async, or if you don't use the send async, there's also send. If you do send, in that case, it will be a synchronous send. But of course, asynchronous send normally too would be more efficient because you don't sit and wait for the results to come back. Yeah, so essentially too, to do producer, kind of send is as simple as, get your handle and then be able to do a send or send synchronous or send async. And then when you're done with it too, then towards the end, you make sure you close it, right? And flush it and close it. So yeah, so it's kind of simplest case can be done as simple as that. Yeah, so. And of course, there are more details too. If you're interested in knowing about the topics, the broker, all of these things, partition, persistence, topic, all of these things, we can discuss more later as well. So yeah.
Cool. So let's
thank you.
Let's see if we can run that then. So if we do, maybe I'll do it on this one, Python wiki. So you can see like it's now publishing them. I've just got this little thing that basically fills in like up to 100% every 100 messages. So we've got some events publishing. What we want to do now is have a look at what events are being published. So I've downloaded a copy of Pulsar to my machine, and I've got the Pulsar client on my shell. So do you want it, Mary? Do you want to just quickly explain these arguments? So we're calling Pulsar client.
Sure. In this case, then on the side of you trying to consume messages, so you can be using this command line, right? CLI to do just consume, and then you consume. You tell it which topic you're trying to consume messages from, right? And then basically, too, there's also the subscription, the -s in here, right? For this one, yeah, would be the Python client, but it works too with other flavor of your client as well. So -s is basically you have to actually specify which subscription you wanted to. And I wanted to kind of point out too, for subscriptions, there are also 4 different modes of subscription. Now, if you don't specify specific subscription mode, then it will be an exclusive mode, meaning that, you are having the single consumer, in that particular subscription. So we'll have one kind of effectively turning, Pulsar into a queuing kind of way of doing things, because you have one producer producing to the topic, and then you have one consumer in this case. So now, and just kind of mention other modes too. You can have like failover subscription mode, or key shared, or actually share subscription for multiple consumers sharing the same subscription. And then also, if you want to make sure your order of your messages get, sent, in the order as it is being sent out, when it deliver you want to have it keep the order, then you can use a shared subscription. So that's what essentially this is doing in here. So yeah, thank you, Mark.
So if we were both consuming messages from the same topic and we had a shared subscription, does that mean we wouldn't get the same one to each? Each one would only go to one of us, or how does that work?
One of us? Yeah. So if you have it sent to like exclusive, then it only goes to one consumer in this case. Yeah. So
okay,
that's what it is. So.
But if you had it in one of the other modes, we could both be getting all the messages.
Be getting all of it. Yeah, that's right. You can use like a shared mode or key share if you want to preserve the order of
maybe after I do this we can find the documentation. Maybe you can send me the link and we can show
that's
people
right.
The different modes.
Sure. Yeah. Okay.
So if we run this, you can see like it is absolutely loads of messages. So let me just kill it. So these are the messages being printed out by the Pulsar client. So you can see we got this is a message. So it's saying, hey, I've got the content here. I've got a schema. I've got the metadata. It looks like I didn't put a key. I guess I should have put a key. Obviously, I didn't put it quite right. I guess you want to have a partition key. Otherwise, it's going to just put everything in the same partition, presumably, right?
Yeah, that's right. Yeah.
Bad me. And then you can kind of see what was being done and what page it was being changed. So it looks like maybe one of the pages in the Library of China. That's interesting.
That is
and you can see the user, whether it's a bot.
Yeah.
I mean, if you scroll up, I don't know, we can see other ones. There's so many bots doing stuff on here. Okay, so at the moment, if we remember the architecture diagram that we had in our slide, so we said we wanted to get it from streaming API into the Python application and into Pulsar. We can kind of see, so we've got that work, we've got the middle bit working. So next bit is, how do we get it into Pinot? So let me just explain to you how data is represented in Pinot. So in Pinot, we're using tables. So we're going to have a table called Wikipedia. And each table, kind of similar to what you would have in a relational database, you need to specify a schema, but it has its own like JSON DSL for defining that schema. And so kind of similar to in a data warehouse, you need to specify what type each field is. So for example, we say, I've got some dimension fields, I've got some metrics fields, and then I've got a timestamp. And so that knowledge is used, the categorization of the fields is used by Pinot to work out how can I store the data, and then when it's querying it as well, like how can it process it. So in this case, we've got an ID, we've got a wiki, we've got user, we've got a title, we've got comment, stream, domain, topic, and so on. And then we don't actually have any metrics in this data set. Metrics would be more like counts of something. So like, hey, I paid this price, I bought this number of items, that type of data, but there aren't any really in here. Like it's all like, hey, one record is a change. And then we've got the timestamp as well. So that's the schema. And then we've got the table config. So those two both go together as a pair. So we've got the Wikipedia schema, and it goes with the Wikipedia table. We specify the schema in here, we specify a time column, and notice that we're using a real-time table. So a real-time table means, hey, I'm streaming data into this table, but you could also have an offline table, and you could even have an offline table with the same name. So for example, we could say, hey, I've got like historical Wikipedia data of changes, I'm going to load that in as well. So we could query both of those two things together. Now, then the next thing we've got to specify is what streaming source are we using? So in this case, we're using Pulsar. And then we need to specify the Pulsar topic. We need to specify where exactly the Pulsar broker lives. This is the consuming type. So this means, hey, I'm going to be able to process multiple partitions from Pulsar at the same time. Other interesting things are we need to tell it, hey, the data is coming from, it needs to be processed with the Pulsar consumer factory, and that we're using JSON messages. Mary, I assume you can I'm using JSON, but you can put other formats of messages into Pulsar as well, right?
Yeah, that's correct. Yes, you have other like Afro, for example, or a protobuf as well. It's also supported.
Okay. Yeah, and so then if we use those when we're getting into Pinot, we would need to use a different decoder.
That's right.
Okay. So and then the last thing to show you is that remember that data. A lot of the data is embedded inside meta, right? It was like message.meta.something, and so in this particular demo, we are using Pinot's transformation functions to get the data out of that meta field and then put it into the column that we need it to be in. So in this case, ID and stream and domain and topic. And then for timestamp, the timestamp that they embed in the Wikipedia data is in seconds, epoch seconds, but Pinot needs epoch milliseconds. Now I'm just going to hand over to Mary because I assume we could have done exactly the same thing using the Pulsar serverless functions if we wanted to, right?
Oh, yes. Yeah, well, it is true. Yeah, I didn't think of that part. I think, yeah. Okay, yes.
Okay.
You should be able to do that as well.
Yeah, so that might be an interesting one for like our next iteration, just to see if we can do it both.
Sure.
Okay, so then we add the table. So I've already actually done it, but I'll just show you what the command looks like. So we would basically go from the Pinot admin, add table, tell it where the table config file is, and tell it where the schema file is. And then we navigate to port 9000. And so what you can see here, so we've got our Wikipedia table. You can see there's new records coming in all the time. So look at this total docs number. Yeah, make it a bit bigger. So we've got 71,765, 71,000, 72,000. And we could let's do something. Let's find out what domain are people searching on. So we can do like all your standard stuff. Say, hey, show me the domain. Group by the domain. So group by domain, order by count, descending. So we can see most of the changes are being made, interestingly, to commons.wikimedia.org. And you could do it for the other things as well. So we can say, hey, I don't know, what would be another good thing? What user is making the most changes? So paste in user there, paste in there. It is PancakeBot has done 10,000 changes since we started doing our talk. It's obviously quite a lot. We've got Flickr, we've got Slurkabot, and so on. Okay, so that's got us over to the Pinot bit. So if we want to do ad hoc queries, this is a pretty good tool for doing it with. But generally, like in user-facing or like applications, or even for people who don't know SQL, this is not a useful. This is not necessarily useful. So we want to go one step further and give them something like a cleaner UI to work with. And so we're just going to show how we can do this with a tool called Streamlit. So Streamlit is a Python library, and you can basically build web apps using only Python code. So you can see how, like, here's like, this is what you can kind of see, like these are the messages coming in. So I think this is like, I started it an hour ago to test it. You can see me testing over here, and then I turned it off, and then we started it again at the beginning of the talk. And so you can kind of see the messages coming in. And we've got like some headline numbers up here. So in the last 1 minute, there's been 2,200 changes by 400 users and 71 domains. Now, by default, like if I go and make a change somewhere, Streamlit will reflect it in there, and but it won't automatically refresh this unless we explicitly tell it to do that. I realize there's a question. So Pinot doesn't support joins. So at the moment, doesn't support joins in the default query engine, but there is maybe I'll show it afterwards. There is like a beta query engine that does support joins, but at the moment people are using tools like Trino to handle that sort of joins. Other question: what if we have multiple entities that we want to aggregate? You have to explain that a bit more. Multiple entities. Yeah, Mini, can you explain a bit more what you mean about multiple entities? And yeah, that's all the queries we've got so far. So let me just show you the auto refreshing version of this tool. So this is version 2. I'll show you the code in a minute as well. So what this one does is it's now got a auto refresh. So we can change that and say, hey, every 1 second, I want you to go and rerun that query against Pinot. And you can see this the little one on this side. It's going up and up and up. And that's because this minute is obviously not as complete as the previous minutes. So this is showing, grouped, show me the changes grouped by minute. And then on the top, we've got just what happened in the last minute. And if we have a look, let's have a quick look at the code. We've got about 5 minutes left. So this is now querying directly with Streamlit and Pinot. So Pulsar is feeding all the data in, but we are now querying directly against Pinot. And this is the query that we're running to do the top numbers. So we're using aggregation plus filtering at the same time. So we're finding all the messages that came through from Pulsar in the last 2 minutes. We're then finding how many happened in the last minute, how many happened in the minute before that. And that's how we're getting the 2 numbers to compare with each other. And then we're doing the same to get the distinct number of users and distinct number of domains. And then we're using this, I really like this feature that it's called metrics. So you basically pass in a metric and you can pass in a value, and then you can pass in a delta. And then let me just show you what would a complete dashboard look like. So it would look something like what we're going to have on the screen now. So instead of just having the changes we can also show you the recent changes that have happened. We can get the who's making the changes, so you can see like the users. They claim like it's weird, like it says only 60% are bots, but I'm pretty sure it's more than that. We can drill down and see the users. So these are the top users overall. So that you see they've all got bot in the name. These are the ones who are tagged or categorized as bots. We've got the Pancake bot, the Shula bot, the Q bot. And then these are the non-bots. And even the non-bots have bot in the name, and they're doing like 3,000 changes in such a short amount of time. They are presumably also bots. Where are the changes being made? So you can kind of see it's as we looked on our Pinot query, it's all in sort of Commons Wikimedia, a little bit on Wikidata, that's their triple store, like keeping track of like metadata of Wikipedia, and then the English Wikipedia, the French one, the Italian one, and so on. This is always entertaining, like the types of changes. I really don't know what like change 142 is, but mostly people are editing pages, sometimes categorizing, and sometimes logging. And then finally, we can drill down by user. So we can have a look. Where are the users making their changes? So that's the Pancake bot. We could have a look at someone else. So this is the Flickr bot. So I'm going to come back. So that's the end of the demo. So I don't think we've got any more questions. I think we kind of got them. If you have any more, please feel free to answer them. But I'm just going to come back to the slides for the last few minutes.
Yeah, there's one more question. Yeah, on the Q&A.
So this is the joining and aggregation. We kind of did that one. Assume we have
there's
shipments, orders, products, inventory. Given an order, if I need to know which products are associated, can I use? Yes, you can use that. I guess like Pinot generally is consuming data from one stream. So if you wanted to join those things together, you would need to join it together in some sort of flat structure that Pinot can then work with. Okay, so just to conclude, so Pinot is being used in lots of places. There's a Slack community that you can join. There's documentation on pinot.apache.org, and people are using it sometimes up to millions of events per second and 200,000 queries per second. If I click to the next one, so that one's for Mary.
Yeah, this one just really quickly, if you're curious who is using Pulsar, it is a newer streaming type of tool, right? It built really for the cloud native environment. But as you can see, we have major, players already using it. Yahoo, Comcast, Splunk, and Verizon, all the Chinese, a lot of the information services company are also heavily using it too. So yeah. Yeah, and then
just to summarize, so hopefully you've seen like these. In this case, I guess the example, the user might be someone who's interested in wiki moderation. It's like, hey, what is going on wiki? That would be like the user using it, and so we can build like these applications where we can see exactly what's happening, right? Like in real time. And the main thing is we've got to have fresh data, fast querying at scale, and Pulsar and Pinot, obviously, as you've seen. Hopefully you agree, it's a pretty good combination for doing this.
Perfect.
This is my conclusion slide. So yeah, as I say, like if you want to find me, I'm Mark Needham on Twitter. If you want to learn more about Pinot, have a look at dev.startree.ai. And as I say, I do 5-minute videos on Learn Data with Mark and Mary.
Okay, and this is me, my Twitter handle. Please follow me. And then also, if you're interested in Apache Pulsar Slack, this is the sign up for it. And then also we have a wiki page over here, community contribution, Apache Pulsar neighborhood is vendor neutral too. So, and then I have a bit more of, these links, I'll be sharing the slides. If you want to know more about Pulsar, Bookkeeper, Zookeeper, DataStax too, we have Astra Streaming and Luna Streaming. And Astra Streaming is the paid tier, although we're giving out $25 per month credit. So it's a continuous $25 per month US dollar. So if you want to play around with Pulsar, please try it on our Astra Streaming platform. And if you want to launch yourself, use Luna Streaming. And then there's also CDC, which is change data capture too. If you're further interested in this capability, please let me know. And Astra DB is our Cassandra hosted on our managed cloud platform. So yeah. Okay, and then also additional information, 5 minutes about Pulsar if you want to learn more is on YouTube. Also, this is the link, or you can search for DataStax developers and you can find the playlist as well. Okay. Yeah, the next one.
Finally,
no, not finally. This one is basically just information if you're interested in learning about all the things about DataStax, Astra offering. All these are free for you to give it a try and learn how to start coding, using streaming, using Cassandra as well. I just thought I'd share while I'm here. So yeah.
And the most important one, Mary's Twitch stream.
Yeah, I actually have a Twitch stream, so I do more coding on there. Normally, I do it Wednesday at 2 p.m. Central Time if I'm not traveling for conferences and such. So this is my Twitch handle, and maybe we'll be inviting Mark to join my Twitch and do some more deep dive as well. So please follow me on there. So yeah, thank you.
Cool.
That's all I
Otherwise,
have.
thank you, and hopefully we answered all the questions. But if you have any more, Robert,
Hey,
Mark, back to you now.
Mark, thank you for a awesome talk. I did have a question. I wonder if you could talk a little bit more about Streamlit. That is kind of a cool looking visualization tool. Where can we get it?
Yeah.
What kinds of things can it do?
So, I mean, I think like a lot of the people are using it for building like machine learning apps, like building like the front end on top of those type of things. But effectively, you are writing Python code, and it is, I don't know, it almost looks like it's creating into some sort of React-ish type thing, but I'm sure it's actually using its own JavaScript front end. But you can basically write, it integrates with all sorts of Python libraries. So we were using Plotly in that one, and the Pinot client driver, but it will integrate with pretty much anything in the Python world. And it's all about, you can do multi-page apps. I guess we saw that. But yeah, it's all about like building, data apps is sort of what they focus on. So it's streamlit.io. Maybe I can, I'll paste the link into the chat in case anybody wants to look at that. Actually, I can't. So maybe you'll have to do it.
Yeah, so my question.
I'll go ahead and post that.
Okay. Cool. So my question
is there
Streamlit is only for Python, right? There's no kind of connector over to Java, for example. Okay. Just thought I'd ask.
Streamlit's in Python. There are lots of other sort of tools that kind of make it, make building, quickly building front ends easier. They do tend to lean towards being in Python or a lot of them are obviously in JavaScript, and then there are other ones which are just even less, literally just dashboarding tools. Like Superset would be a commonly used example of that. But this one is Streamlit kind of gives you more control, but obviously you write more code to get it to work.
Sure. Okay, gotcha. Thank you.
Yeah, like Superset would be another example. So I like just show you that quickly. So Superset is more for building visualizations, like charts of stuff, and it's more it automates more of it for you. So it's kind of more like go to a UI and click around stuff, and it will connect hey, here's my schema. It will connect it up to a Superset schema, and then allow you to build a chart probably more quickly than what you can do in Streamlit once you've got it configured. But obviously you're working within the constraints that it has, whereas Streamlit you can probably do whatever you want.
Very cool.
Cool. So
Great.
I guess, we're at our time. So maybe
I think we're at time. I've just posted the link to Superset.
Super.
Mary
Thanks.
and Mark, thank you so much. Really informative talk. I love seeing the stuff you guys are doing, and it was super informative.
Thank you.
Cool. Thanks
thank
for having
you
us.
again,
Thank
Robert,
you, everybody.
for having us, and thank you, Mark, too. Thank you, everybody. So.
All right. Bye, everybody. We're going to call
Bye-bye.
it a day on this webinar. There's going to be a break before the first keynote starts. It'll be coming up in 16 minutes. So talk to y'all soon. Bye-bye.
Thank you. Bye. Bye.